Hello, I'm your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends with leaders and innovators who make it all happen. On today's episode, we're absolutely honored to be joined by Intel Automotive's Jack Wiest and Rebecca Delgado. On today's episode, we'll learn how Intel and SAE are developing battery standards, but more importantly, how collaboration, standards, and trust can unlock efficiencies. Jack, Rebecca, welcome to the podcast.
Thanks for having us.
So happy to be here.
It's great to have you here. I love the old saying Intel inside, and now you're going from the computer to the vehicle. Jack, how's Intel approaching automotive, and will my car eventually have an Intel Inside sticker on it?
Yeah, in fact, there's tens of millions of cars on the road today with Intel Inside, and most people don't know it. So we're being a little bit more public with our strategy. But here's how we approach things. The automotive industry is going through a pretty existential change right now. The industry is going to look completely different by the end of this decade than it has, for the century before. And so we're approaching this from a point of view of let's help the industry solve some of its biggest challenges. And as we look at the many challenges the industry faces, we think there are three that Intel is uniquely situated to help them with. The first is the vehicle architecture, based on dozens and dozens of ECUs, each with a lagging node microcontroller in it, needs to move to a software-defined architecture, just as other industries like industrial and telecommunications have done. And so this is something Intel knows how to do and something we can help with. The second, electric vehicles. Batteries are getting bigger and bigger, heavier and heavier. So we've got to start working on the efficiency side of the equation. And at Intel, we went through this journey 20 years ago with laptops. Early laptops weighed many pounds and had a battery life, if you're an hour, if you were lucky. So we started working on the efficiency side of the equation, and now we have laptops that last, an entire day. And then third, the industry really needs a better and more scalable solution. Vehicles range from ultra luxury all the way down to kind of entry segments. And the industry's never had a technical solution that's scalable top to bottom. And again, at Intel, we've learned these lessons as mobile computers span from Chromebooks to high-end mobile gaming PCs. So we've had to solve each of these challenges in other industries. And so we're pleased to be able to help the industry with each of these problem areas.
Rebecca, I remember I had an old clunky Dell laptop. I think it might have weighed 9 pounds. And it had the battery you had to replace on the bottom and had the plug in. And Jack said maybe you're lucky if you got an hour. And if you overclocked it, then you got less power. Or if you were downloading something, this was when cable modems and DSL first came out. Oh, you're taking more power, and you had to keep it plugged in all the time. But the team at Intel, every generation of a chip, the power got better and better and better. Are you learning from the engineers on the chip side, from the computers, of what you're putting into the vehicle from their experience that they've had?
Well, like any technology advancement, it has multiple vectors of advance, right? But besides the compute efficiencies where you get more performance, for effectively the same power at the chip level, in reality, some of the biggest lessons is what Jack was alluding to, right? Intel at the time completely understood that the original system of a computer was, to be designed to be plugged to the wall. And the mindset had to be changed to deliver that value to the user, where you didn't have a 9-pound laptop that only lasted for 1 hour, right? Technically, that's not very portable, right? Effectively. So what we did at the time, and this is exactly where we're borrowing lessons from, is that Intel led the industry into the adoption of a new way to do power management at a system level, and that coordinated in an interoperable way all of these components that were going to have demand on power, right? So borrowing from those exact concepts is what we're driving here in the automotive industry by chairing that new SAE committee to deliver an automotive standard that focuses on power management at a vehicle level. And the idea here is to help all industry to be more energy efficient and more sustainable.
Rebecca, is that taking the best of what you've learned from the transition from desktop computers to laptops? Now you're taking it because at the end of the day, an EV or a car is a rolling computer. Are you just basically the natural evolution of where you were going with that energy management?
Exactly. That exactly the analogy we would make here, right? Intel saw the need, 25 years ago on evolving how the industry collaborated for a better, efficient compute system from a power management perspective, that we are exactly at that moment in the automotive side of things, right? As compute needs evolve and the consumer experience is directly attached to range, right? The main focus will be around energy management efficiencies and how Intel can borrow from that leadership and understanding on how to do this best through standards and open approaches.
I think Rebecca said something that's kind of interesting about a mindset change. If you think about a PC plugged into a wall, you had kind of a limitless energy source. So all the components that were on the PC platform or all the peripherals you had plugged in, you didn't really need to worry about conserving energy because there was plenty of energy to go around. That's a great, analogy to internal combustion engine vehicle platforms where even at idle, there's so much energy to go around that you leave on the floor. We've never really had, as an automotive industry, to think about energy conservation. So, nearly all of the ECUs that are inside a modern vehicle run at full power all the time, whether you're using them or not. And those lessons learned from our efforts to improve battery efficiency in mobile computers to say, hey, if I'm not playing audio, why is the audio DSP powered? Or turn the display off, as sometimes we get annoyed happens. But all of these things that are happening automatically are part of that mindset change to say, hey, I'm not running on I'm not connected to a limitless energy source, so I need to conserve energy. And so in that same mindset, if you just take a combustion engine platform, rip out the engine and put in a battery, you've got, equivalent of a desktop computer draining your battery across the entire vehicle platform. So we've got to take those same lessons and apply it to the whole vehicle platform.
Jack, you're right. It seems outside of a handful of OEMs and EV startups, it's just you take hi, this is a chassis for traditional ICE. Let's just slap a battery on it and away we go. And we've all seen the nightmares. I have one that somebody did that. This OEM did it. And the battery goes 80%, 20%. And then a couple hours later, it goes back to normal. And you're right, it runs at full power. And it just seems like there was no thoughts. And so I call and I complain and said, sir, we get these calls every day. I said, are you going to fix it? We're actually canceled that line of vehicles. Okay, but if they called you, they could have fixed that. Why was this efficiency mindset never in there in day one, which was just this rush? I'll give you the term, the California gold rush. Was it chasing this EV gold rush? Is that what this was, where there wasn't thinking through, calling experts at Intel, say, wait a second, there's no internal combustion engine to power this thing. It's not a desktop anymore. It's a laptop. Hello, we've got to figure this out. Why was that mindset there, do you think?
Yeah, I think, obviously the market's trying to the industry is trying to get EVs to market as fast as they can. So expediency sometimes is the goal rather than efficiency. But I think as Rebecca noted, part of the challenge here is if you think about the supply chain of all the different ECUs that get delivered that make up a car, in order to have that whole vehicle platform level view on energy management, the entire supply chain needs to get behind an open standard and an open, non-proprietary way to manage energy. And that's going to take time, but that's a perfect role for the SAE and standards. And that's what we hope to be able to solve here, that with this standard, you'll have an entire supply chain of tier ones and tier twos providing ECUs that implement this standard and then finally allow that automaker to be able to manage energy across the entire vehicle platform, where today they can't, because the interfaces are proprietary, or frankly, they don't exist, because those ECUs were never designed with that mindset to begin with.
I mean, exactly like Jack said, right? It all comes down to that mindset, right? And the OEMs have a lot of challenges, that they're dealing with at the same time. There's multiple transformations going on at the same time. Ideally, we would have at least done one at a time, but the reality is that we're all dealing with these quite seismic transformations happening, right? So this is exactly how Intel wants to come across as a thought leader that can help innovate and pretty much lift all boats, right? And truly create a coalition of the industry, truly solving some of these biggest problems, while still completely enabling differentiation and freedom of choice, right? So we're really focused on a very critical element of how can we all speak the same language at a vehicle level when it comes down to doing power management. Everybody has to do it. It is not trivial for a single OEM, a new OEM, to rally the whole industry behind it, right? So the idea, this is exactly where consensus-driven standards shine, right? Where you bring all of the subject matter experts and everybody together brings best practices for the industry to accelerate in a direction.
Rebecca, when you look at developing the vehicle platform management standard, you mentioned supply chain. Will you go all the way down the supply chain? There's a movement, especially in the EU, around track and trace of minerals. Will you go that far down in the supply chain, or how far down in the supply chain will you go as you look to develop that standard?
Well, I mean, truly, the standard might sound very simple because it's really, that's why I use the analogy of language. The standard's very focused on everybody agreeing on how to define vehicle power management at a complete vehicle level. So it's truly a focus on interoperability. When everybody agrees on interoperability, then it allows for an ecosystem to deliver value to a pre-existing way of how to exchange these capabilities and features, right? So no, the standard's not going to boil the ocean in going into every layer of what requires to deliver an electrified vehicle focused on efficiency. What the standard is focusing is how can this very, very complex system focus in this particular area that everybody has to go and create, and instead of creating a proprietary manner, that we all agree on how to talk to each other in the ecosystem to deliver more efficient power consumption and demand at a vehicle level, right? So at the end of the day is for the ecosystem to worry less on how to integrate their solutions into OEM A, B, C, and D, that at the end of the day burn engineering and technology cycles, right? And focus then purely on delivering more efficient components to make to build then in collaboration in this industry with all of the suppliers more efficient vehicles at the end of it all. So the standard is quote unquote very simple, but at the end of the day is something that sometimes the most obvious things are in front of you and you can't see because you're so focused on what you're trying to solve, right? And when you take a step back and say, hey, we're all doing the same thing, why don't we collaborate and agree on the specifics of everybody speaking the same language when it comes to power management? Then the OEMs can then focus on the bigger problem statements, right? Truly advancing the technologies and some more critical sciences behind what makes an electric vehicle possible, right? So the OEMs and the technologies behind electrification will continue to have to evolve, but we don't have to wait to make progress until those leaps in technology happen.
Jack, as Rebecca and the team and various other of your counterparts in the industry work on developing a standard, at some point we will get a reacceleration of electric vehicles, which I look at the supply chain. Is there enough natural resources that are readily available today if when we have that next big spike in the demand for electric vehicles globally, not just in one region?
Yeah, I think most of the data and studies that I've seen say we don't. And that's all the more reason why we've got to focus on the efficiency side of the equation, because batteries just keep getting bigger and bigger and more expensive. It's getting more difficult for an automaker to even make a profit on an electric vehicle. So if they can build a vehicle with the same range, but a much smaller or lower voltage battery, not only saves them money, so it improves their profitability, but it uses less of those raw materials. So it's really kind of a win-win for the auto industry.
Rebecca, Jack stepped into us, and I'm going to ask, from a technical standpoint, how do you make the battery lighter? We've also read the reports, we've heard on the news. The batteries weigh a lot. The microplastics are coming off. I think it was a report in the Atlantic around the salmon in Washington State and the issues that it's having there. We've seen the brake dust increasing because of the weight of the battery. Technically, how can you make the battery lighter without reducing the range that consumers globally so want and cherish?
Well, I mean, the reality is that this is the technologies that I was talking about, right? So there's a lot of technologies being explored out there, like solid state batteries and so on and so forth are the aspiration goals. But in the meantime, with the current proven technologies that are being scaled, one of the initial efforts is to move from like a 400 volt electrification system to an 800 volt architecture. And the benefits here is, well, number one, you can charge those vehicles faster, right? So back to the user experience, you have a certain range, and the 400 volt and 800 volt battery could have the same capacity of power in total. But by going into these new architectures, what you do is, you simplify, you reduce the charging time, but at the same time, because you are now having an electrification infrastructure that is going to be running effectively at lower currents, then that sustaining infrastructure of the vehicle to the same capacity of battery, just because you're changing the topology, let's say, of the electrification, will translate into lighter cables, connectors, components. And at the end of the day, that element of the system subsystem then will correspondingly be lower cost, right? So the industry is looking literally at all of these mechanisms to lighten the electrification infrastructure. The battery technology will evolve at its own pace, and these novelties. Obviously, everybody is betting on different approaches, and everybody's investing in that domain. What the industry is focusing as well, and not to switch into product, but at Intel, because we have this holistic vehicle perspective, we're very focused as well on solutions for how to extract the most efficiency out of the electrification controls, right? So at the end of the day, what makes the battery lighter is that the demand from that battery is as efficient as possible, or each one of the components in the vehicle that are making these demands. And that gets done through smarter controls at each one of these stages. And Intel has product offerings focused on that. But at the end of the day, where Intel is coming back to the table to collaborate with the industry is then let everyone deliver differentiation in each one of these ingredients that make a vehicle more efficient and more sustainable, while at the same time enabling the ecosystem to deliver faster in a standards-driven approach on how to deliver power efficiencies at a vehicle level through the J3311 standard.
Maybe I can add an example. If you think about a vehicle, or actually let's use an example that goes back to laptop days. Today in current laptops, you actually don't produce a constant rate of voltage from the battery. You actually dynamically vary the voltage level based on the needs. And so if you're turning things off, you need less energy flowing through the platform. So the same could apply to a vehicle platform. So if it's winter in Michigan, why is the air conditioner ECU powered? If you're charging, your EV, why is the ADAS ECU turned on? Or you're parked, or you're just sitting in a parking lot. There's all sorts of examples where you can optimize if you had a common language across these ECUs to be able to turn things on or off deterministically. And so if you reduce the demand, then you reduce the amount that needs to be drawn. And then in aggregate, you don't need as much energy to be stored over time because you're optimizing how much energy is needed throughout the drive or the entire period where the vehicle's on, where in most cases, you probably rarely get to peak draw because you're always aggressively, managing energy for things that don't need to be on based on the current driving mode or weather conditions or topology of the road or things like that. So it's really taking a whole vehicle platform approach and looking at things in aggregate all adds up to significant savings, which conserves the amount of energy that you need. And then ultimately, could lead to smaller and lighter batteries because you don't need as much energy stored to deliver the same experience.
Jack, what you described is common sense.
Yeah.
But there's no other way to say it. It's common sense.
It really is.
But why was that not applied until you came together with industry?
Well, in the IT industry, we didn't think we needed to do this either until we had battery powered devices. So the auto industry is just finally there where vehicles are battery powered, and now it's time to learn from other industries and take some of these common sense approaches that have been used for literally decades in IT devices. And so these are proven concepts. We know they work. And so that's why we're confident that this standard's going to be incredibly successful in helping the industry gain the same efficiencies that the IT industry gained by doing the same things.
And usually standards, that's what they are, right? A distillation of common sense of what subject matter experts have arrived to. But then at the end of the day, it drives economies of scale, because if everybody's on the same page on how to distill this common sense through an agreed document that we're going to all abide by and then evolve over time as, we know better than doing better, right? It truly comes down to that very practical matter of Why do we go all and create these common sense practices in a proprietary siloed way? Let's all just collaborate and join forces to advance the industry. We are not gonna afford to do in any other way, as it's being proven, as the industry is grappling with the complexity of these technology changes.
Rebecca, the standard's going to take a while. You're going to have to get consensus. You're going to have to go to voting. We can go down standards row. It's not going to be, you're not going to turn the switch on as the laptop and biddity boppity boop overnight. You have a standard. It's going to take a while. When you do have a standard, there'll be millions of vehicles in the wild globally that do not meet that standard. You've pioneered it. We have the internet. Intel runs on the internet. Is there a way that you can push over-the-air updates to some of those older vehicles to increase the efficiencies?
I mean, the reality is that as the industry is transforming to these more software-defined vehicle infrastructures, maybe not cars that are like 15, 20 years old, right? That will, just to dial up the contrast here. But as we move forward, we do think that there is a very software layered approach, on how to continue to deliver an evolving mechanism on doing this context awareness of how energy is utilized in the car, right? So Jack spoke about the examples of, hey, as I have awareness of what's going on from a weather perspective, that means that the traction, it's going to be raining, the traction for my tires is going to be such, and we can then slowly start to evolve the adoption, right? So our vision is that it's going to start very explicitly around powertrain, like the demand for more efficiently estimating range, right? For example, and then slowly but surely it will trickle to the rest of the subsystems in the vehicle, right? So the idea here is that as an industry, we can drive some of these solutions that are kind of like de facto adopting some of these concepts, right? Some of the most advanced OEMs already do power management, right? The idea is then slowly over time to start to translate some of these into more of a standardized set of literally implementations, right? But the idea is let's do a crawl, walk around as needed, right? The industry cannot afford to wait until everything is all I's dotted, T's crossed. Just having this level of discussions is creating very, very interesting conversations with the ecosystem and customers. The reaction and it's very much as you said, it's common sense, right? So it truly, when you speak to these technologists and these leaders that are looking at all of the ecosystem needs around this, everybody sees the value in cooperation and collaboration. How it exactly that is deployed, there will be, areas where we'll take traction sooner than later, but that doesn't take away from that long-term view. At first it might feel slow, but one of my favorite sayings here is saying that slow is smooth and smooth is fast, right? So if we bring this to a table ASAP, then it'll be available sooner than later, and then we can help the industry adopt.
I like that. It's smooth. We did a SAE demo days in Detroit, and there was this very nice woman. She goes, I said, how was it right? She goes, it was smooth. And that's what you're ushering in. She said it was smooth as a Cadillac, and it's true. That was the symbol back in the day. So we're going to stay on Detroit here, Jack, because you mentioned winter in Detroit. Well, why do you have the air conditioning on? It's cold outside. You want the heater on.
Yep.
How much, if you look at outside data sources, these vehicles can pull in data. Are you going to pull in weather data when you start to look at the battery optimization? Well, the vehicle knows, okay, it's winter in Detroit or it's summer in Arizona. Are you going to look at those types of data to help optimize the battery where you're not going to have to think about the vehicle automatically already know?
Yeah, absolutely. And this is why we say that you can't solve this problem one ECU at a time. You've got to take the whole vehicle into consideration and take a systems perspective. So, you mentioned range estimation and how kind of wildly inaccurate that could be. Consider an example where, you're driving in a valley, it's, sunny and 70, but you're headed up into the mountains. So not only is the road topology going to change considerably and burn a lot more energy, but the temperature is going to drop, 50 or more degrees. And so the battery chemistry is going to change. And so now everything you thought you had about range to get to your next charging station is now wholly inaccurate. And this is the opportunity for the industry as we look at the whole vehicle and all of that rich context that exists inside the vehicle in terms of who's driving, how many passengers are there, what's the weather, what's the route. And if that information is shared, vehicle wide, with the energy management subsystem, you have an opportunity to not only perhaps more aggressively manage power, just like we do on our phones, go into that low power mode to make sure you can get to that charging station, or just quite simply provide more accurate range estimation, to the driver, because now you're taking into consideration, all of that context. And so that sentiment is absolutely part of Intel's vision, and why we think it's important to think about not only cockpit solutions, but also energy management solutions, and then even the humble microcontroller, because there's still going to be a lot of ECUs in the car, hopefully a lot less, but those ECUs still consume energy. That air conditioner ECU, the seat heater ECU, whatever it might be, the screens in the back seat. And if there's nobody there, why is those screens powered? For example, there's all these opportunities to more aggressively manage energy and keep in mind the driver's goals and priorities, which might be getting to the destination, or it might be performance, because you're having fun on a track day or something. And so all this different context can make the power or the energy management subsystem much more intelligent if you give it whole vehicle visibility. And that's exactly what this standard would enable.
Jack, to enable that vision that you described, what role will sensors play? You can put sensors where they know, okay, nobody's in the back seat, don't turn on the screen. Is that going to be, are sensors going to be what's going to enable that?
Yeah, for sure. Like you said, or the weight of the vehicle. How much, what's the, not only just the passenger weight, but what do you have in the trunk? Do you have a couple bags of cement, or maybe it's an electric truck, and so you got a heavy load in the bed? Obviously, that's going to make a massive difference in your range. But if all you're doing is just checking with the battery management subsystem and saying, hey, just give me a metric that's a measure of the energy in the cells, that's kind of, it doesn't make any sense even to consider that with all that other context. So I think there is a significant opportunity to bring all that information together. But as Rebecca said, you can't do it unless all of the different elements of the vehicle are interoperable. If that sensor that's giving you that weight information, speaking a proprietary language that can't be understood by the power subsystem, then it doesn't have an opportunity to more accurately give you that range estimation. So it just shows the value of open standards, where there's still going to be a lot of differentiation in terms of the different modes that you offer, how aggressively you manage energy, what you do with that intelligence. That's all fair game for automakers to innovate and differentiate. But you start with a foundational common language where all the different ECUs can find each other, understand what power they consume, and provide open and standard interfaces for an intelligent entity within the vehicle to be able to manage their energy consumption.
Rebecca, I'm going to put it in simple terms. How do you get everybody to be nice when you're developing this vision where everybody talks to everybody?
That is the ultimate human element of technology, right? At the end of the day, you have the laws of physics, right? Literally the chemistry of the battery and, the topology of a road, and then literally the impedance of your copper cables that are carrying, and all of those are very challenging problems. But the ultimate problem here is the industry aligning and collaborating in the areas that will bring value to really how we participate, in this industry, to society and as people, right? This is where Intel collaborating with SAE is literally our preferred approach, right? Consensus-based standards versus, consortia, guys more as marketing mechanisms, right, of proprietary technologies. The idea here is truly bringing subject matter experts to the table, bringing that common sense. I love how you brought it here, to really find where are the immediate needs of creating that common language of agreement of, hey, we are all in awareness of these energy efficiency set of requirements. Now let's put it in paper, right? Let's literally define a dictionary of terms, a combination of baseline elements necessary for everybody to be able to deploy these solutions in a accelerated and simplified manner, right? There's really no value in everyone developing this from scratch. There's just so many hours in the day and so many people working in these problem statements. So the more we focus in areas of collaboration that are not, do not have proprietary value, the faster we will get to having a multitude of solutions that are all focused on delivering to more sustainable vehicle platforms. And sustainability is not just from an environmental footprint, like Jack shares usually in his introductions of our strategy. This sustainability has a huge economic and resources impact, right? As we were starting at the beginning. So yeah, that is exactly the purpose of standard bodies, to bring the humans to agree on common sense approaches.
I'll add, Grayson, I think the one thing that gives me hope is like you said, there's nobody that we haven't talked to about this standard that says, oh my God, that's a great idea. We should do that. The support has been universal in terms of the recognized need, and the opportunity to do this, in a consensus-driven manner, because there's truly nothing proprietary here that gives anyone an advantage. It gives everyone an equal opportunity for additional differentiation and value that they can bring, because it focuses on the entire supply chain. That doesn't advantage, any one particular automaker over the other. So we're confident that human element can be overcome when you've got everyone aligned to a common goal.
Standards make the world go round. There's no way to put it. You want to go from
They do.
You want to go from home to school, school to home without a standard. We'd have Barney and Fred Flintstone.
Yeah, stop signs
and Dino
are
Yabba Dabba
standard.
Doo.
Yeah, we forget. Street signs are standards. Traffic lights are standards. Our basic infrastructure is built on standards, many of which come from the SAE. So that's why we're really honored to be working with the SAE and believe it to be the right organization to do this in the right way, in a totally open, consensus-driven manner, where anyone can participate. So we're thankful for the partnership with SAE to get this off the ground.
Well, we're thankful for you. Could you imagine if there was no stop sign standard? Oh, this one means go. This one means stop. We'd have like Rumpaville. It wouldn't be very nice. Rebecca, obviously the driving functions in an EV it's called, we'll use a PC term, it's a battery hog. It's going to use a big chunk of the battery. Outside of the critical driving functions, what are the other big draws on the vehicles? Is it the air conditioning? Is it the screens that seem to get bigger and bigger? What is that big draw?
Well, I'm gonna bring it first and foremost to driving, right? Obviously, driving is the main feature of a car, right? 'Cause, that is the reason why we have these devices, to call them something, right? So obviously the EV battery and the electrification subsystems are there to propel the car, along the way in the road. But steady driving is, the biggest differentiator on how much driving consumes. So not to be like super Captain Obvious, that's why we have regenerative braking systems and so on and so forth. So there's an element there of context awareness too, right? On how the driver prefers to drive, and compute intelligence will always help with these elements, right? So the efficiency is there of utmost importance, right? But back to Jack, how he was talking about the example of, you're in the city, you want to go up to the mountains and the weather changes. What does that mean for your range estimation? The biggest impact to range estimation and literally the chemistry of the battery is temperature, right? So weather conditions will always be a necessary input, right? But this is the purpose of the standard, right? So to have this clear way to understand what the vehicle components are going to be demanding, overall, and weather conditions are going to be informing a lot of the environment in which these vehicles operating. Obviously it has to drive within certain topology because of where you're going from a destination. So that informs, your map driving and your mission planning of where the car is going from A to B. But what are the weather conditions, right? That literally impacts the chemistry of the battery subsystem. And then the next element that drives demand, then it's going to be the HVAC. Controlling the cabin temperature, again, completely related to weather conditions, right, is going to be the next biggest power drain in the vehicle as of today. However, and if you Google this, you won't see this very directly attached because of the consumer expectations. We're all attached to our personal devices way more than we're all willing to acknowledge. But as the consumer expectation changes, the car experience is more and more directly digitized and attached to compute. And we see a 4x increase in demand in compute in the vehicle over the next, 5 to 10 years. And when today, the compute elements in the vehicle are not considered possibly necessarily the biggest draw, they will continue to grow in being one of the biggest demands to that battery subsystem, right? So at the end of the day, this is where tying it back to why Intel brought this to a table, attaching it back to consumption of power due to compute, borrowing from our lessons learned from the PC world and the standards that we drove 25 years ago for the ecosystem to know how to best do power management, power demand, and doing this in a context awareness is why we're building the foundations of the concepts around for the J3311 standard for power management.
Yeah, let me add to that. I think that's an important point because a high performance compute system, let's say, that can consume 50 watts, at full power, or some even more than that. If that's full power all the time for the entire time period in which the vehicle is on, that really starts to add up, But if you don't need it, if you're just cruising down the highway and all you're doing is listening to music, turn part of that big compute system off as well. Maybe not completely off, but now it operates in a lower power mode, just like our PC devices do. You might have 8 or 16 cores inside your PC, but they're not all being used all the time. And when they're not being used, they're idle. And as we're talking here, other subsystems might be on, like the camera, the audio subsystem, but maybe the SSD is powered off because we're not really doing much in the way of reading and writing, right now. So even within those big compute subsystems, as compute grows in the vehicle, the standard's going to provide opportunities to optimize energy within those larger power-consuming ECUs as well.
Jack, Rebecca said a 4x increase. That's pretty astronomical. But now I'm going to play chef. I'm going to throw another ingredient into the pot here. L4 autonomy. Are we going to add on zeros? Or are we going to start multiplying this? Where are we going with that?
Yeah, I think it's anyone's guess. I think, looking at some systems out there, you could definitely add a few zeros. But I think this is where necessity is the mother of invention, as you say. And so I think there's some emerging approaches to more intelligent algorithmic approaches that solve the problem in different ways that maybe don't require as much compute and as much power. And so I think eventually the industry will come around to figure out how to do that because, practically speaking, if you add a few zeros from an energy consumption standpoint, think what your battery life would be or how bigger that battery would need to be for that robotaxi to actually operate all day. The math just doesn't work. So all of this is part of helping to contribute to that challenge.
We have a lot of listeners from the EV industry, traditional automotive. I'm going to ask this to both of you because I'm really curious. Intel has a long heritage in developing really great server chips, laptop chips. You can go down the line of all chips that you've developed. Jack, we'll start with you. What can the EV industry learn from the PC industry? Is there a takeaway that for the counterparts that are listening from the EV industry that you'd like to them say, hey, we've already learned this in the PC industry. You can apply this to the EV industry?
Yeah, I think you said it great, actually. I think my message would be, don't worry. This is a solved problem. And so we can help. And it's proven in use, for decades. Certainly there's differences in a vehicle platform. You have different kinds of communication buses. You have different levels of compute, different kinds of sensors. But there's nothing fundamentally about these concepts that shouldn't apply. And frankly, that's our message, not only in terms of energy consumption, as we've solved that problem with mobile computers, but also with software-defined architectures. They're new. They look complex. They're difficult. They come from the data center world. It's frightening to a lot of folks in the automotive industry who spent their life on embedded microcontrollers. But again, my message is don't fret. We've helped other industries like industrial or telecommunications move from, custom embedded ASICs to, high performance general purpose compute. The 5G networks globally run on open general purpose compute, software defined infrastructure, and it works. So it's just the same process that we've got to go through. So having seen this and been there before in other spaces, we're confident that the industry will make this transition, and we're very happy to be able to help.
Rebecca?
I think another way to look at it as well is the high performance compute, the client compute industry has to work with every human, every industry, every institution on the planet. And automotive has historically been, let's call it lucky, to operate in a fairly insular vertical of a solution, right? So what I would incite, very much to what Jack said, right? The technology side of the world had to deal with a lot of these problem statements so that we could deliver value across many, many applications, use cases, and conditions of deployment. So we've had to work in a collaborative way. Think of what would the compute world look like without USB and Ethernet and Wi-Fi and 5G and so on and so forth. All of these efforts are international level of cooperations on where there's laws of physics, at the baseline of spectrums and communication payloads and thermals of compute chips and silicon manufacturing and so on and so forth. But where the industry had to collaborate to create these very widely deployed technologies, it required cooperation, collaboration, and open compute, open standards, and actually open source, if I was getting down to the crux of some of these technologies. So bringing back this to the J3311 effort, this is exactly the mentality we're bringing to the table. Think about USB, think about Ethernet, think about all of these other standards that truly created an ecosystem where nobody thinks of USB as like a proprietary standard anymore. Everybody's just focused on how do I integrate to the right to the right version of the standard so that my charger works, so that my tablet charges as fast as possible, and so on and so forth. These are the exact same problem statements that we're seeing in the automotive industry today, where technology cannot advance fast enough and deliver economies of value for the OEMs and the end consumer without collaboration and cooperation and standards is a means to that end.
If we didn't have collaboration standards, and I'll add another key element, trust. The world wouldn't go round. Information wouldn't flow. You mentioned it. Without Ethernet, one of your core businesses, data centers, wouldn't exist without Ethernet. We wouldn't be having this conversation today without Ethernet and without your chips in data centers, because that was built on collaboration, standards, and trust. Jack, Rebecca, this has been a fun conversation. Intel's going to make it a huge difference in automotive. My vehicle can go from here to there, and I'm not going to have to worry about 40, 90, 40. Oh, no. Oh, no. My wife's yelling at me that we're going to have to pull over and charge because the vehicle's not going to work. You're going to solve that problem. And at some point, maybe, Jack, you put an Intel Inside on the vehicle, maybe in the glove compartment. I'm sure you'll find it somewhere. But for today,
we'll find a spot.
You'll find a spot. You're good at that. Then if you get those really cool guys to come out and do that dance, like similar to what you did with the Blue Man Group, that would be fun too. For today, as we look to wrap up this insightful conversation, what would you like our listeners to take away with them? Rebecca, we'll start with you, please.
Well, my call to action to the listeners is please join us, collaborate, bring your common sense and your ideas and proposals to SAE, to the work group J3311. We're very excited to be having these discussions on how to best create this new language for power management at a vehicle level.
Jack?
And I'll just reiterate, we're here to help. We're happy to be able to provide the expertise that we've learned by solving these problems in other industries. And as Rebecca noted, help the automotive industry get out of its silo and learn from other industries who have been here before. And we can help make the auto industry successful, more profitable, and more sustainable at the end of the day.
The automotive industry can learn a lot from the PC industry. Call the friends at Intel. They understand collaboration. They understand standards. They understand trust. Today is tomorrow. Tomorrow is today. The future is Intel. Jack, Rebecca, thank you so much for coming on SAE Tomorrow Today.
Thanks, Grayson.
Thank you so much, Grayson.
Thank you for listening to SAE Tomorrow Today. If you've enjoyed this episode and would like to hear more, please kindly rate, review, and let us know what topics you'd like for us to explore next. Be sure to join us next week as we talk about the future of autonomous and electrified trucking with Continental.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.